Please welcome Sanchin Raj, Principal of Data Science and Advanced Analytics at AT&T, who brings to us a talk on the synergies between predictive and causal models in customer churn reduction. Welcome.
Many years ago, I learned that when you teach a child how to model trains, you most likely keep him out of poverty and weeds. But in the recent past, I have learned and observed that when you teach a child to train models, you not only make him the world's richest, but one who can smoke all its weeds. You are looking for a joke, I tried. It's difficult to convince data scientists, especially the last time. But anyway, very thrilled to truly share a few lessons I have learned over the years. My name is Sanchin Raj. I work for AT&T as a practitioner of data science solutions for many of the business challenges we have. Moved around small biz, mid-sized area of work, then went to consumer, then returned to the enterprise unit, working under the marketing analytics. What I am going to talk about, you have seen these numbers, and if you haven't, you probably got dropped from another planet here. These have been independent numbers published by different institutions, but you put them together, something emerges, that the impact to market is literally less than 1%. AI has not stood up to its hype when it comes to market impact. We can all agree on this one, that all of the models, the analytics that we develop and deploy are around decisions. And those decisions are tightly tied with return on investments. So now why failure? Why that AI has not stood up to its hype? Some of us touched on some issues and challenges that we face in our organizations, right? And I think, I'm convinced on this, the most important challenges come from a lack of cohesiveness, a disconnect among these three things: models, model outcomes, and ROI. And if you go further deep inside, you will figure out, I would try to find a solution or find a problem and dive deeper and understand why. You will see these keep coming, that we keep using vanity metrics. Talk about accuracy rates. We talk about F1 scores. These can take us to a large degree, directionally. But by the end of the day, when it comes to returns, these do not have any assumptions that are baked into it. You will see these metrics don't have any connection with the actual business outcomes. For instance, and I'll touch on that. And then ultimately, we have methods and procedures for model development, structured thinking for everything. But then when it comes to stakeholdering, we have business partners, we have data scientist teams, that there isn't a framework, a cohesive structured thinking of how a problem is developed, stated, and taken to market or taken to production. What I'm going to propose is sort of a practical suggestions. A few lessons I learned over the years, that when I would see these issues, I would strive hard to figure out why. And some things that I have identified as 4 issues for which I have these 4 solutions. Things like, hey, if you do not have a KPI that ties with, or a business KPI that doesn't tie with your model outcome, engineer one, right? CLV, or rather, let's say churn modeling. We have a predictive outcomes that clearly gives us a propensity score. But then we look what? Volume. What is the connection? Almost nothing. Know, very important, that the value of insights are extremely important, or rather sometimes more important, than your predictions. One of us gentlemen touched on, we have all these models, we take them to production, and nobody cares. Why? That's exactly the problem that I attempted to diagnose. And eventually, when I use these little ideas, or rather, in my view, causal thinking or the why thinking, not just for the model outcome, but start from even before developing the model. You start developing these early insights, and you work with your partners, and you will see some evidence of what I'm talking about. The third point. We guys all don't even think about the benefits of classification in terms of dollar value. But often overlooked even further, never even considered, even if you just think about benefits, is the cost of misclassification. You have no idea sometimes that a little change in the cost structure could completely destroy your model outcomes in terms of the lift that you produce. And the last point is take advantage of the power of persuasion, which means think about uplift modeling. Anything causal inference that brings to the table that eventually could produce much higher marketing returns. The first one, I've structured this as a problem that you would see, and there is sort of a recommendation and some evidence, and then we will track down to the solution itself. The four problems that I've identified are around this particular business problem, right? Predict churn, and also find why. 2 months ahead, 3 months ahead, figure out what churn. So it's a combination of predictive models and prescriptive models, causal inference, right? So I am assuming, based on all of the work that I've heard or listened to, we will have the coexistence of predictive machines coexisting with causal inference. So in this case, you have model, it's working well, right? You take them to market, but then about a month or two later, you want to find what my actual lift was. It had very high lift when you developed it. And now you see nobody knows. Not a single soul in your company knows. What's the point of developing a model if nobody can track it? Of course, it's sometimes complex. You have channel attribution, very many complex channels running together. But you can trace it back down to a single reason that your model outcome does not tie with the KPI or the business KPI. CLV is a classic example. Think you can feed your model outcome directly into CLV. And CLV can attack many wide variety of predictive problems because it takes margins, takes a discount rate around risks, and then feed the churn propensity into it, and you get a pretty good outcome. But when you think like that, the solution again is, right, if you don't have one, find out one. You're all mathematicians, statisticians, you can cook one, right? Develop one, engineer one. But the benefit of this is you think about looking at a more granular level, right? It forces you to consider the different cohorts of customers. Customers with higher retention rates bring larger value, unlike the lower ones. And so, marketing teams do have the ability to target different types of customers this way. Secondly, again, you have a great model. You roll out in production. Nobody cares. About a year later, you find out I had 200 models in production, 30 of them used. Why? So you talk, you go to a stakeholders and find out you have these little processes that you look at the check marks. They all consider that's a check mark that this particular campaign really used a model, or rather, that's a check mark. Nobody knows what they used for. They just looked at it. They never used it. They didn't even log in to look at the scores. And long story short, you will find out things like, hey, look, my sales compensation is based on the number of calls I make. It means the first, second, third quintile or quartile or whatever that you develop from your list of million prospects, or in the case of churn, customers. Nobody cared because it only produced about 30,000. They wanted 300,000. And so you work hard all years, and how do you make a change? It is not a model problem. It is not anything else other than a company strategy problem. How do you influence strategy? How do you bring change? And I have found that you can move needle, that when you work very closely with your stakeholders, partners, by finding these early insights. This is a data set from Kaggle, right? And I put it out, and you figure out that some of these customers have Simpson's paradox problem, some of these profiles, where you see the customer with a contract type who signed up for a month over month and 2-year contract, both have long tails, but completely opposite behavior. Right? When you share this with your stakeholders, you create these aha moments. You create this trust. You partner with them very closely, and then you create an anchor in the culture where they trust your models. And slowly you start seeing the usage of the models go up. Nobody likely heard about half-time value, customer half-time value. You think about 50% of the customers, whoever signed for the 6-month contract, leave in about 6 months. Here, more than 50 stay for almost 6 years. These are valuable inputs where your stakeholders can take this information and develop your campaigns for the specific projects. Another problem, which is models were great. You took them to production, aha moments creator, but somewhere things got screwed up. Nobody knows why. There is big disappointment. And now you try to diagnose and you figure out what happened. It's a simple example from that same data set. That here is a model outcome, right? You have a classification matrix. You put together the number that is like about 80% accuracy. You have a cost of, cost of the what do you call? It's an average cost of, the false positives and false negatives. That you just keep in mind that costs are not they're not symmetric. That I simplified it just by taking this the symmetry cost. But keep at 130, and you barely made your case. Your model worked, right? But then with the same outcome, same 80% rate, your price or the cost improved or made it worse by a few cents. But from 130 to 2, you are underwater. So now you use some feature engineering, spend a lot of time, push about 100 from here to the other side, right? And all of a sudden your model accuracy rate went up to 85%, and then you feel pretty good. With the same accuracy rate, let's say your billing got screwed up, you became liable for something. You ended up spending money, paying back customers. You're completely underwater again. The point being this, that misclassification costs are very vital, very important for us to understand and dissect and think way ahead in terms of average costs that you put together in practice before you can really convince the stakeholders and ensure that they agree upon, they understand what the challenges are, what the underpinnings are before you take the model to production. Lastly, a similar problem, you have a high rate of success in terms of the model outputs as you developed it. But then you have about 14% of true positives. and you tell this to your stakeholders, the immediate understanding and expectations are something like, are we going to get 14% conversion? Something like that, right? It is quite naive, but you go about the campaigns, and then you end up having about 3%. Lift is just about 3%, which is darn good. In a randomized model, you just pick a random, leads, or in this case, customers, you will likely have about 1% at max, or much less than that. But this is providing much more lift. Then what happened was the complaints start pouring out, which is, hey, look, I had 14%. We ran a large campaign. Think about it. We run at large scale. It's millions. And then every time you spend $1 or $2 for a promotion cost, for an email that you sent out, it adds up. And so we run these large campaigns, and they simply, come back to haunt you where you wasted a lot of money in marketing spend. And the question is, can we just target the persuadables? Practically, that is where the next steps would be, where we can be prudent in using an uplift model, understand SEMs, and more about, think about these SEMs as some things that can contribute to stakeholdering and building the trust early on as a suggester to provide early insights to the stakeholders as you model through. So this is some of the lessons I learned, and it comes down to thinking about a couple of key points. One is, I often get called on to solve some complex problems. And it goes about the thinking, right, can we add more data? The lesson I've learned is that there is a decremental or declining value for adding more data. At some point in time, it's not. You can add as much as you want, but it all goes back to playing some fundamental rules, going back to the basics, and think from the stakeholders' point of view. And equally important, as someone else pointed out, avoid these jargons, build the trust, and think from the dollar value point of view, and then you take it all to production. I think you will start moving the needles. Now, look, I think the few things that I wanted to suggest are things that I learned over the years. Now, are they going to move mountains? I don't think so. Are we out of the woods yet? No. If you think about what pundits would say the challenges are in the as a field, you would see some pointing out, we have this infrastructure issue and our models are failing or data is not good. If the data is good, then you talk about skills, and then if the skills are good, then you have MLOps problem. You go on, and then comes down to, okay, causality. Hey, look, there's all BS about correlation. Now we talk about causal thing. Okay, we got it. Now we come to this. Are we out of the woods? Well, look, I think it's a journey, as we pointed out. And if we, as practitioners, think causally, not from the model outcome alone, but as I mentioned, as a framework, as sort of power principles to keep in mind. Maybe you can add more than this or eliminate one of these, right? But think from that vantage point and put this into practice. I think we will start making or moving the needles. And so when you keep moving the needles, one here, one there, eventually I think we'll end up moving mountains. That's my story.
Thank you, Sanchin. Perfectly timed. Very impressive, very impressive. But I'll squeeze in one question for you. Can you give some examples of the vanity metrics you mentioned earlier?
Which?
The vanity metrics.
Accuracy rate is a vanity metrics. I would call it simply, it'll take you to some extent. F1 score is a vanity metric. There is no thing. Why am I calling it that way? Because accuracy rate can be inflated or deflated just by adjusting a threshold. Your stakeholder might be impressed by a 92% accuracy rate. You can figure it out. A clever data scientist can sit and squeeze a few adjustments there, and you can produce a 98% model accuracy rate. And that's why I call it as simple as that.